I forgot to turn my microphone on, so I'm just going to have to narrate this. We'll see how it goes. It's not going to be live narration anymore. It's going to be narration after the fact. So here's a problem with an infinite plane of charge, uniformly charged, uniform charge density per unit area, sigma 0. But this plate has a hole in it. So if it were a uniform plate, then you could just use Gauss's law. And it starts to look like you might need to do an integral over the whole plate because you can't use Gauss's law anymore very simply because it's not uniform. But in fact, here's an example of a situation that's a little like the last one. The last problem had two spheres, and you could use Gauss's law for each of them to calculate the total field. Here, you can calculate the total field of the infinite sheet, as is shown here, as I'm showing here in this drawing, to find the electric field along the z-axis due to an infinite sheet that was uniform. And then what's the effect of the hole? Well, if you think of the plate as positively charged, then the plate with a hole in it is equal to a positively charged plate plus a little circular piece that's negatively charged. So the infinite sheet is positively charged at sigma 0. The little hole is like a piece of negatively charged circle. And if you put those together, you end up with the infinite sheet and the negatively charged sigma 0 and positively charged sigma 0 at that circle right there cancel each other out. So that's the equivalent of a hole. So positively charged sheet, negatively charged hole, negatively charged circle in the center is equivalent to the sheet with a hole in it. And so you use Gauss's law for the infinite sheet. You use an integration to find the electric field along the z-axis due to that little disk that has negative charge. You add those two electric fields together and you find out the total electric field due to the infinite sheet with a hole in it.